Now, before we go to the another questions, some examples, I will discuss the important results. Now, what are the important results? Important results are if f and g be the continuous functions. If we have two continuous functions, f and g be the two continuous functions, then their sum, f plus g. If we add the two continuous functions, if we subtract the two continuous functions, if we multiply the two continuous functions, then the new functions formed are all continuous. यानी अगर हमारे पास दो continuous functions हैं, उनका sum, उनकी difference और उनका product जो है वो भी continuous है. और अगर उनका quotient लेंगे fx divided by gx, वो भी continuous है, मगर provided gx is not equal to 0. ये जो डिनोमिनेटर है इसका डिनोमिनेटर फंक्शन 0 के बराबर नहीं होनी चाहिए, तभी ये कंटिन्यूअस बन जाएगी. हाँ, c times fx is also continuous. What is c? c is a constant. So then this will also be continuous. So remember, if you have any two continuous functions fx and gx, so f means fx and g means gx, right? So मैंने simplified form में लिखा, instead of fx मैंने f लिखा और instead of gx मैंने g लिखा. So if you have two functions f and g, then their sum f plus g, f minus g, f into g, they are all continuous. And fx divided by gx is also continuous, but provided gx is not equal to 0. And c times fx is also continuous, where c is a constant. Now we'll take an example. A function fx is defined as, fx is equal to, now this is the piece function, 1 plus x is less than 2, 5 minus x is greater than 2. So ये हमने ब्रेकअप में दे दिया, दो फंक्शनों का ब्रेकअप दिया है. ये फंक्शन का ये है 1 plus x when x is less than 2. It is 5 minus x when x is greater than 2. Is this continuous at x is equal to 2? We have to justify it. We have to justify whether this function is continuous at 2 or not. Since the function is a piece function, so we have to find the left hand limit as well as the right hand limit. Because we know the definition of continuity is we have to find the limit and the value. If limit and the value is same, the function is continuous. Since the function is given in the breakup, it is given as a piece function, so we have to find the left hand limit, we have to find the right hand limit, we have to find the value of the function. If all the three are equal, then we can conclude that the function is continuous. Now we'll come to the solution. Solution is limit x tends to positive fx, because we have to find both the limits. So fx is equal to 2 positive fx. It is equal to limit x tends to 2 positive. Now what is 2 positive? What is the function when we approach 2 through the positive values? Because we know it is 2, we can approach through this way or we can approach through this way. So these are the values which are greater than 2 and these are the values which are less than 2. So once it is 2 positive and I am approaching 2 through the positive values के लिए x is greater than 2, उस वक्त मेरा function जो है that is 5 minus x. What I will do, I will write 5 minus 2. 5 minus 2 will become 3. So this is our first limit. Right hand limit. Now limit x tends to negative fx. It is equal to limit x tends to 2 minus. 2 minus के वक्त, less than के वक्त, it is 1 plus x, which is equal to 1 plus 2, which is equal to 3. Now see, what is the right hand limit? It is 3. What is the left hand limit? It is also 3. Right? Now left hand limit and the right hand limit are equal. Left hand limit and the right hand limit are equal. Now we have to find the value. What is fx is equal to? Where is equality in the question? Equality is here. X is less or equal to 2. Equality के वक्त मुझे लिखना है 1 plus x. जिस वाले पोर्शन में इक्वलिटी है वही वाला लेना है. So 1 plus x. What is f2? What is the direct value once we put x is equal to 2? It is 1 plus 2, which is also equal to 3. Now see, left hand limit is equal to the right hand limit is equal to the value of the function. See, left hand limit is equal to the right hand limit is equal to the value of the function. Therefore, fx is continuous at x is equal to 2. Therefore, fx is continuous at x is equal to 2. So that means this function is continuous at 2. So this was our example, and I will take now another example. Now this is the example number 2. This is the NCERT example, NCERT question also, आपकी textbook में भी है. Show that the function gx is equal to x minus greatest integer of x. Now you know this is the greatest integer of x. Is discontinuous. I have to show that this is discontinuous. This function is discontinuous at the integral points. Now you know what are the integral points. Integral points are integers. So this function is discontinuous at every integer. Here this symbol denotes the greatest integer of x less than or equal to x. This denotes the greatest integer of x less than or equal to x. So the function this, we have to prove that this function is discontinuous at integral points. Now how to solve this? I'll come to the solution. You take the question like this. It is gx is equal to x minus greatest integer of x. You take x is equal to a, any arbitrary integer. You take any integer a, any integer. Now, I have already told you that once there is a greatest integer, we have to find left hand limit as well as the right hand limit. See, limit x tends to a positive gx. That is, limit x tends to a positive gx is x minus greatest integer of x. Instead of this gx, I have put x minus the greatest integer of x. Now, I am approaching a, but through the positive values. I am approaching a through the positive values. That means, through the positive means a plus h. So I will put x is equal to a plus h as x tends to a, h tends to 0. Therefore, the limit h tends to 0, x is a plus h minus greatest integer of a plus h. What I have to do? I have to put x is equal to a plus h here as well as here. Now, which is further equal to limit h tends to 0. This is a plus h as it is minus. Now you know it is a slightly greater than a because h is very small. So it is a plus h. It is a plus slightly greater than a. Whose greatest integer is again a? Because you know if you have 2.1 ka greatest integer, that is 2. If you have 2.7 ka greatest integer, that is also 2. If you have 3.9 ka greatest integer, that is equal to 3. Because you know this is the definition of the greatest integer. So if you have a plus slightly more than, that is a. So what you will do, you cancel this a and h is 0. Once you give h 0, it will give you 0. So the right hand limit is 0. So this is the right hand limit of this function is 0. Now what we'll do, we'll come to the left hand limit. Now how to take left hand limit, I will tell you. So left hand limit is, now you remember this right hand limit is 0. Now we'll see what is the left hand limit. Now left hand limit is limit x tends to a negative gx. That is limit x tends to a negative, gx is again x minus greatest integer of x. Now I am approaching this way. So this is a minus h. Now I will put x is equal to a minus h. That is, as x tends to a, h will tend to 0. So this will become limit h tends to 0, x is a minus h minus a minus h. Now that is limit h tends to 0, a minus h minus. Now see, a minus h, a से थोड़ा सा कम, a से थोड़ा सा कम, अगर 2 से थोड़ा सा कम होता है, 2 से थोड़ा सा कम होता है 1.9, सो 1.9 का ग्रेट इंटीजर 1 होता है, यानी वो 2 से 1 कम होता है. अगर 3 है, 3 से थोड़ा सा कम, दैट मीन्स 2.6 का ग्रेट इंटीजर 2 होगा, यानी वो 3 से 1 कम होगा. सो व्हाट इज द greatest integer of any number which is less than 2? That is 1. What is the greatest integer of any number which is less than 3? That is 2. What is the greatest integer of any number which is less than 4? That is 3. So what is the greatest integer of any number which is less than a? That is a minus 1. a से a कम. जैसे ये 1 है, ये 2 से 1 कम है, ये 2 है, ये 3 से 1 कम है, ये 3 है, ये 4 से 1 कम है. इसीलिए a से जब थोड़ा सा कम होगा, that will be a minus 1. Now I'll simplify this. This is limit h tends to 0. a minus h minus a plus 1. a and a will get cancelled. Now you put h is equal to 0 and you will get the limit 1. Alright? So what is the left hand limit? Left hand limit is 1. Earlier right hand limit क्या था? वो 0 था. So हम लिखेंगे here left hand limit is not equal to the right hand limit. So limit does not exist. Once limit does not exist, left hand limit is not equal to the right hand limit. Therefore the limit does not exist. Therefore fx is discontinuous. Sorry, gx. Gx is discontinuous at x is equal to a. So it is discontinuous at x is equal to a. So this limit since does not exist, therefore once limit does not exist, once left hand limit is not equal to the right hand limit, that means the limit of the function does not exist. When limit of the function does not exist, we conclude that the function is discontinuous. Where it is discontinuous? It is discontinuous at a. What is a? A is an integer. Now instead of a you can take 1, 2, 3, 0, minus 1. So that means this function is discontinuous at all the integral points. That means this function is discontinuous at all the integral points. That means this function is discontinuous at all the integral points. So this means we have proved that it is discontinuous at all the integral points. Now this is another example. This is also textbook question. That is fx is equal to x sine 1 by x. Very important question. X sine 1 by x when x is not equal to 0, and it is equal to 0 when x is equal to 0. So x is not equal to 0, its value is this. When x is equal to 0, its value is, it is given. Find whether fx is continuous at 0 or not. So you have to check whether this function is continuous at 0 or not. So what we'll do, we'll find the limit at 0, then we'll find the value at 0. If limit and value is same, then we can conclude that the function is continuous at 0. If they are not same, we can conclude that the function is discontinuous at 0. So I will come to the solution of the question. Now what is the solution of the question? I will break up the question. I will take two cases. Limit x tends to 0 positive fx. That is limit x tends to 0 positive x sine of 1 by x. Alright? So I can put, just elaborate this. It is 0 plus h. As x tends to 0, h will tend to 0. Because I am approaching to 0 through the positive value. So I will put x is equal to 0 plus h. So this is equal to limit h tends to 0. Instead of x, I will write 0 plus h. Then sine of 1 by 0 plus h. That is limit h tends to 0. H into sine of 1 by h. Because 0 plus h is h. 0 plus h is h. It is 1 by h. Now once you put h is equal to 0. Now have a look here. Please make it understand here. It is 0. Then it is sine of 1 by h. Once you put x is equal to h, don't give x is equal to directly h, but give some value, it is tends to. It means it is very nearer to h. So sine of any angle, you already know sine theta is between minus 1 and plus 1. The value of sine theta always lie between plus 1 and minus 1. You know it from the trigonometry that sine theta always lie between minus 1 and plus 1. So whatever be the value of h, this will lie between plus 1 and minus 1. So it is any value between minus 1 and plus 1. We don't know what is the value, but we know that value lie between minus 1 and plus 1. So that is a finite quantity. So finite quantity multiplied by 0 is always equal to 0. So what is this limit? So what is the right hand limit? So the right hand limit is equal to 0. So we conclude here the right hand limit is equal to 0. Now we'll come to the left hand limit. So what is the left hand limit? I will come here. Limit x tends to 0 minus fx. That is limit x tends to 0 minus x times sine of 1 by x. Now you put x is equal to 0 minus h. as x tends to 0, h will also tend to 0. Similarly, मैंने अब instead of 0 plus h मैंने 0 minus h लिख दिया. This is limit h tends to 0, 0 minus h, here 0 minus h, sine of 1 upon 0 minus h. Because instead of this x I have put 0 minus h, sine of 1 by this is 0 minus h. So it is minus h, sine of 1 upon minus h. Right? That is limit h tends to 0. That means limit h tends to 0. Now what is sine minus theta? Sine minus theta is minus sine theta. That will become plus. So it is h sine of 1 by h again. So it is again 0 into any value between plus 1 and minus 1. So again it is h is 0 because it is 0. Any value between plus 1 and minus 1. So 0 into any value between plus 1 and minus 1 will become equal to 0. So what is the left hand limit? It is 0. What is the right hand limit? It is also 0. So both the limits are 0. Now the last thing. You please have a look on this. First of all, I obtained one limit, right hand limit, 0 plus h. And I have proved that it is equal to 0. Then I have obtained the left hand limit. That is also equal to 0. So left hand limit and right hand limit both are same. So limit exists and is equal to 0. Now what is the value of the function? Now value of the function is what is f0? f0 is, see f0. f0, once we put directly x is equal to 0, it is given it is equal to 0. So the value is also 0. So what is the solution? Left hand limit is equal to the right hand limit is equal to the value of the function. Because in this case, left hand limit is 0, right hand limit is 0, and value is also 0. Therefore, we conclude fx is continuous at x is equal to 0. So we conclude that this function is continuous at x equal to 0. So my question was find whether the function is continuous at 0 or not. So I have proved mathematically, first of all I have proved that the left hand limit is 0, then right hand limit is 0, then the value is also 0, therefore all the three are same, therefore the function is continuous. This is how to solve this example. Now after this I will take another example. Now another example. Another example is, it is slightly different again. Find the value of k. Now we have to find the value of this k here, which is in the question. Find the value of k so that the function fx, so that this function is continuous, so that it is continuous at the indicated points, at the indicated point. Now what is the indicated point? Indicated point is x is equal to pi by 2. So the question is, we have to find the value of k so that this function is continuous at x is equal to pi by 2. So it is given that it is continuous at x is equal to pi by 2 and we have to find the value of k. Now how to find the value of k? I will tell you the solution. See the solution. First of all, you find limit x tends to pi by 2 fx. Because we know when the function is continuous, its limit and the value is same. So first of all, I will find the limit. So limit is limit x tends to pi by 2. fx is when x tends to pi by 2, that means x is not equal to pi by 2. When x tends to pi by 2, that means x is not equal to pi by 2. It is not equal to pi by 2. So it tends to pi by 2. Once it is not equal to the pi by 2, then the value of the function is k cos of x upon pi minus 2x. Now if you put directly x is equal to pi by 2, if you put directly x is equal to pi by 2, cos pi by 2, cos 90 is 0. 0 into k will become 0. Divided by pi minus 2 into x is pi by 2, that is again pi. So pi and pi cancel, that is 0 by 0 form. So we cannot put directly x is equal to pi by 2. Because by giving directly x is equal to pi by 2, the function becomes indeterminate. So what we'll do, we'll apply the procedure of limits. So what we'll do, we'll put x is equal to pi by 2 plus h as x tends to pi by 2, h will tend to 0. So you will get limit h tends to 0, k times cos of pi by 2 plus h, then divided by pi minus 2 into x की जगह फिर से pi by 2 plus h. Now see what I have done. K as it is, cos as it is, but instead of x, pi by 2 plus h, divided by pi as it is, 2 as it is, x की जगह pi by 2 plus h. Now I will simplify this. Simplification is limit h tends to 0, k into, what is cos 90 plus theta, because pi by 2 is 90. So what is cos 90 plus theta? This is minus sine of h. This is minus sine of h divided by pi minus h, because 2 or 2 cancel and 2h. This is 2h, right? Now that is further equal to pi and pi will get cancelled. This is limit h tends to 0. This is minus k sine of h divided by minus 2h. Now remember this thing. K sine of h divided by minus, this is minus 2 times h. Now what is sine h by h? We know trigonometric limits. Sine h by h, when h tends to 0, it will become 1. So minus and minus will get cancelled. So the limit is equal to k by 2. So its limit is k by 2. So k by 2 is the limit, because minus and minus will get cancelled. So it will be k by 2, and the sine h by h, sine theta by theta will be equal to 1 when h tends to 0. Remember, h tends to 0, this limit will become 1. So it is equal to k by 2. So what is k by 2? K by 2 is the limit of this function. But what is the value of the function when x is equal to pi by 2 directly? The value is 3. So value is 3. Value is equal to 3. Now since the function is continuous, because he says it is continuous at x is equal to pi by 2. It is continuous at the indicated point. So it is continuous function. So once it is continuous, that means k by 2 must be equal to then 3. That means k must be equal to 6, because 3 2s are 6. So the value of k should be then 6. Then only this function will become continuous. So if we put k is equal to 6, then only this function will become continuous. If we put the value of k other than 6, this will not be continuous, this will be discontinuous function. So what I have done, first of all, I obtained the limit of this function. What is the limit of this function? Limit of this function is k by 2. Then value of the function at x is equal to pi by 2, the value of the function is 3. So limit and the value both are same. Once limit and value are same, here they are not same, because he says it is continuous. Once this is continuous, so what I have done, I have put k by 2 is equal to 3. When k by 2 is equal to 3, the value of k is equal to 6. So the value of k is 6, then only this function is continuous. Now, another example. For what value of lambda, again the similar type of question but slightly different. For what value of lambda is the function this continuous at x equal to 0? So this is the first part of the question. Question says, if the function is continuous, then what should be the value of lambda? Right? But it is again piece function here. It is in two parts. Less than x के लिए अलग है और greater than x के लिए अलग है. So we have to take the two limits. So solution is limit x tends to 0 positive fx. It is limit x tends to 0 positive. What is 0 positive? It is 4x plus 1. See, it is 4x plus 1. When x is greater than 0, it is 4x plus 1. Now you put x is equal to 0, it is 1 simply. So one limit is 1. What about another limit? Limit x tends to 0 minus fx. That is limit x tends to 0 minus. 0 minus is when it is less than 0. Less than 0 is here. It is lambda times x square minus 2x. Once you write lambda as it is, you put x is equal to 0. 0 minus 0 is equal to 0. That is equal to 0. Now see, what is the right hand limit? It is 1. What is the left hand limit? It is 0. So here, left hand limit is never equal to the right hand limit. So left hand limit is never equal to the right hand limit. It can be never, whatever be the value of lambda. Because this part becomes 0. So whatever be the value of lambda, this will always be equal to 0. If lambda is 1, 1 into 0 is 0. If lambda is 2, 2 into 0 is 0. If lambda is 10, 10 into 0 is. If lambda is 100, 100 into 0 is 0. So whatever be the value of lambda, this portion will always be equal to 0. It will be never equal to 1. So what I will conclude, so once limit does not exist, limit does not exist. When limit does not exist, function is discontinuous. Function is discontinuous at x is equal to 0. So this function is discontinuous at x is equal to 0. So whatever be the value of lambda, so no value of lambda, now I will write like this, no value of lambda will make function continuous at x is equal to 0. So no value of lambda will make the function continuous at x is equal to 0. Okay, this is the first part of the question. Now the second is, what about the continuity at x is equal to 1? Now what about the continuity at x is equal to 1? Now for x is equal to 1. For x is equal to 1. What is 1? 1 is a number which is greater than 0. 1 is a number which is greater than 0. So for greater than 0, we have to write 4x plus 1 only. So in that case, what we have to write? We have to write fx is equal to 4x plus 1. We have to write fx is equal to 4x plus 1 because I have to find the continuity. I have to discuss the continuity of this function at x is equal to 1. Right? But 1 is a number which is greater than 0. So I have to take, in that case, I have to take only 4x plus 1. So I will discuss here now. Once I have to discuss for 1, I have to take this function. What about this function? If you clearly see, this function is a polynomial. This function is a polynomial of degree 1 because 1 is a power. And we have already proved in the previous lecture that any polynomial, every polynomial is continuous everywhere. Everywhere it is continuous. So this is continuous everywhere. So this is continuous at 1 also. So I can conclude, since this is a polynomial of degree 1 and we know that every polynomial is a continuous function everywhere. So this is a polynomial. So this will be continuous everywhere. So this will be continuous at x is equal to 1. So what about this question now? This question is, this is never continuous at 0, whatever be the value of lambda. But this is continuous at x is equal to 1. So this was the solution to this example.